Hello all, welcome to CAE Bootcamp. In continuation to our module 1 and module 2, today we are going to discuss about the 3D meshing. Like what is a solid geometry and what are the topology lines indicates for the 3D geometry, and we'll create one tetra mesh for the one component which you have already got in our Decibels website. And after doing the tetra meshing, we'll check for the quality parameters for the same component. And if any other necessary checks required to finalize the 3D modeling or 3D elements or tetra elements. We'll get started. The image, as you can see here, for this component, today we are going to measure. This is one of the engine component. The left side one is the represent the CAD modeler, and the right side one is the finite element model. I have used tetra elements. So before proceeding to the creation of the tetra elements, we'll have some small look on what are the solid geometry. See, today's agenda is what is solid geometry and creation of the volume tetra elements. We can create the tetra elements by using the 2D elements also we can create. And if the geometry is a solid one, directly we can go and create the tetra elements on the surface itself. Then we are doing the standard tetra meshing. This is what majorly we are using, the standard tetra meshing. And tetra remeshing, as we discussed in the module 2, the same way, once the software gives the tetra elements, if the elements are not meeting the quality parameters, or sometimes if the elements are not captured properly, then we will go for the remeshing option. Whether it might be a 2D elements or it might be a 3D tetra in 3D elements, might be a tetra or hexa elements also will do remeasure. Then the same way how we did for the 2D elements, we are checking the quality parameters for the tetra elements. See, this is how our solid geometry looks. All the geometry for the CAE purpose or in any of the design CAD, we will get with the solid only. All the components will come with the solid geometry only. If we require the solid geometry, we will be carrying with our machine. If not, we will delete it. Usually, for doing or creating any elements, we are not bringing we are not carrying the solid element with us. We will not carry, as a CAE engineer, we will not carry the solid elements, since we have an option of extracting the mid surface. To extract the mid surface, the solid geometry is not required. But when it comes for the creating the 3D elements, we require a solid geometry. Why? Because there are two options are available to create the 3D elements. We can generate by using the 2D elements also, or we can generate using the solid geometry itself. On the top layer of the solid geometry, our elements will get created. But for any of the design, see, once the CAD data is finalized from the design engineer, obviously it will come with the solid CAD only. If you want, we will carry. If not, we will delete it and we will take it further. See, as you can see in the image, this CAD image, see, this green line indicates the bonding phase, and the yellow line indicates the full portion, and we can call it as a duplicate line also. And these are the two solids. We'll look in HyperMesh. See, as you can see, this is my solid geometry. Here, you can see some of the green lines are highlighting. Here, some of the green lines are highlighting. It indicates it contains solid geometry with us. See, it contains solid geometry. As we did same case in the module 2 for the 2D elements, components are, see, all the solids are in a different collector or different component. The same topology corrections as we discussed in the 2D model, the same way. See, the green one indicates the shared line, the green one indicates the shared one, and here you can see the yellow ones, it indicates the duplicate surface for this solid. And the same way how we did the topology corrections for the solid geometry, the same thing. If you want to toggle, you can toggle it. See, it will applicable for the solid elements, solid CAD also. But once the solid geometry is deleted, I will show you. See, as I said, the highlighted green lines are, it contains solid in it. So I'll go for F2. F2, we will use it for deleting. I'll go for the F2. Search for the solid option. See, in HyperMesh, whatever we are creating, whether it is a solid surface, lines, geometry, elements, whatever it might be, a load, system collectors, whatever it is, we are having the same option for deleting. One thing we have to keep it, these are the options which we can create in HyperMesh, that can be deleted. The delete option is available in F2. I'm going to select the solid one, fit the model. See, solid by, you can go by selecting a one solid also, or else say solid displayed. See, in a single shot, all will get deleted. Now you can observe the highlighted green lines are not there. Even though if we delete the solid geometry, we will have a single surface or volume surface. Now, for the 2D meshing, we are going to carry with it. If it is having a lesser thickness, we will extract a mid surface and we will proceed it. But if the component is having a higher thickness like this, if the component is like this, then what we will do? We will go by creating the hexa elements, or we will go by creating the tetra elements. It's both the choosing the elements, the same way how we selected the 2D elements, the same way it will depend on the project requirement and the time and the type of analysis we are doing. Sometimes what happen, if we don't have a time, see, for this component, we don't have much time to mesh this component, or else we need a urgent results for this component. Sometimes not in a sometimes majorly for the CAE industry, there is a requirement of urgent results for all the components. That time what we will do, we will choose tetra elements instead of hexa elements. This is one of the advantage of using tetra elements. Doing a tetra meshing is easy compared to hexa elements. That time what we will do, just we will go by creating the tetra elements and apply the same load condition, boundary condition for the respective components, and we will extract the results. But later, if the results are satisfied, or if the results are the extracted results are closer to the accurate results, then we will go by creating the hexa elements. But as I said, it is depends on the time. If you don't have a time, we are choosing tetra elements. And sometimes there is a demand of component. For example, say, consider one engine component. See, for the component like this, doing a hexa meshing will be difficult. Why? Because there are so many features to capture and it will take more time to mesh this one. Say, for example, I'm telling, to do tetra meshing for this component, it may take 3-4 hours. But to do hexa meshing for this component, it may take 4-5 days. So for this reason, there is a demand of component. It means if you consider any of the engine component, that for those components, there are more features will be there. We have seen the engine component manually in our automobiles. That time, for the engine component having more features, it will be having more fillets and curved faces it will be having, and it will be having many the surfaces are not planar. There is a deviation in the surfaces. Why? Because to manufacture the casting component, obviously there will be more features. That time, on the demand of the component, we are choosing tetra elements. This is the theory behind why we are choosing the tetra elements. Next, coming to the solid geometry, see, after this geometry, what are the elements are available in HyperMesh? What are the elements which we can use in HyperMesh? See, we can use tetra elements, we can use pyramid elements, we can create hexa and the penta elements. We'll see one by one how it looks in HyperMesh. First, I'm going with the tetra elements. See, as you can see in this HyperMesh, there are few elements are there. See, I'm just observe the highlight of the element. See, if you can observe, see, it is highlighting till this node. It means it is a solid element. we'll see how the shell elements, as we already know how the shell elements will be. See, if I highlight the shell elements, see, if I highlight the shell elements, it will look like this only. It will look like this only. But the solid elements, will highlight. See, will highlight. We'll mask some of the solid elements and we'll see. I'm going to highlight few of the tetra elements. See, these are the tetra elements. As you can see, these are my tetra elements. See, it will highlight. It indicates it is an 3D elements. It is a 4-noded element. So 4-noded element means it doesn't mean like it is a square or rectangle element. It is an tetra element. But how the hexa element looks, we'll check that also. See, as you can see in this image, we have here tetra elements also we have, penta elements also we'll have. First, we will check the penta elements. I'm going to highlight the penta elements. See, even though it looks like a tetra elements, but it is an penta element. See, as you can see, this is 7 nodes. See, these are the penta elements. Don't get confused with the tetra elements and the penta elements. Now, we'll see how the hexa elements will be. I'm just giving an information about the elements. See, these are the hexa elements. This is 8-noded element. It's like one cube. See, you can observe it's like one cube element. This is an hexa element. These are the 4 elements which are available in HyperMesh to create any of the 3D meshing. And we know how we create in the 2D elements. There is a requirement of triangular element. Why? Because to match the element density, in the same way, we are using both the hexa and penta elements for creating the brick element or hexa element. For completion of this brick element, we are using one is hexa element and one is penta element. But in the case of tetra elements, when you are going to create a tetra elements, see, here we are going to use first order element, tetra element or pyramid element. For my component, I have created only the tetra elements. See, these are my tetra elements. And you can see, if you come here, see, there is a difference in the element visualization. If you can observe closely, there is a difference in the element observation. What it is means, as I said in our last module, there is a difference of first order and the second order elements. Now, I will see, this is an 4-corner tetra elements. We'll check for the tetra 10 elements, how it looks. See the highlighted one. See the highlighted ones are, these are the tetra elements. And I said in my last module also, see, observe then these nodes which I have created. Observe these nodes. These are the first order elements. The same way, the same concept which we use in creating the 2D elements, the same way and the same concepts is applicable for 3D elements also. But if you come here, just observe the node count. I'm just creating some temporary nodes. Observe it here. This is an second order element. It means one node in between the corner nodes. This is a tetra 10 elements. This is tetra 10 elements and this is the first order nodes. These are the different elements are available to create any of the solid geometry. These are the element concepts or these are the elements availability which are available in HyperMesh to create any of the solid geometry. See, we have seen tetra, hexa and penta elements. Now, we'll move on to creating the Tetra Elements. As I said, to create the Tetra Elements, we can create it by 2D elements also, or else we can create it by only using the solid surface. First, we will create a Tetra Elements using the solid. See, my component having some solid with it. See, keep it in a mixed mode for the representation. See, as you can see, this is a complete solid, and I can delete this solid and I create the 2D elements and I can do it. But sometimes, see, if the component, see, for this component, I may go directly by creating the volume elements. Where it is available for the, see, in the menu pages, come for the 3D. In the menu page, I'm going to select the 3D for creating any of the 3D elements. For 2D, I can select the 2D page, but I'm interested to create in the 2D for this model. I'm choosing the 3D page. In the 3D page, search for the Tetra Mesh. Here the Tetra Mesh is available. Select this one. Here the third option is there, volume Tetra. It is asking solid. So I need to select my solid. Select the solid. See, if it is in if a component contains a solid, means of it in a single click it should get selected. If not, your component does not contain the solid with it. See, select this one. Here we are using element sizes for mm. You can change it here. You can make it as 2, 1 according to your requirement, and the curvature and the proximity we are using based on the demand of the component. For the curvature section, you can select like this. See, you can select these surfaces and you can mesh it. Use the proximity means sometimes what happen here, you may require the 1 mm mesh, but here you may require the 4 mm mesh. Based on your requirement, you can choose these two options. The same way, the 2D type and the 3D type here. The advantage in creating the volume Tetra, at a time, it will create 2D elements also and 3D elements also. To represent any of the 3D models, to represent any of the 3D elements, we require 2D faces. Even though if you are not creating the 2D elements, there is option in the software, we can directly create the 2D types. Need not to worry for creating the 2D elements. When you are using the volume Tetra, don't create any 2D elements directly. Here it will get selected. See, in the 2D type, see, there are the options are there which are available in the functional key F12. The same option are available. You can by creating the tria or tria mixed, but whether you are choosing mixed or tria or whatever it is, but the 3D type will be Tetra only. See, the 3D type will be Tetra only. See, I'm going to choose the equilateral triangle, select the solid and say mesh. See, you can observe in the status bar. Now it is ready. After creating a Tetra element, see, automatically the collector will get created. Here I didn't create any component to keep the 3D elements. The software itself, it has created the 3D elements. Now observe the elements. See, there are equilateral triangles are created. See, here the equilateral triangles are created. But you need to observe one thing here. Since it is a curved surface, here equilateral triangles are created. But my requirement is different. Why? Because in the CAE industry, we are not keeping equilateral tria in the curved faces or in any fillets. Or the surfaces like this, or the curved features, or when we want to represent the sum of the bolts, means we are not going to keep equilateral trias. Why? Because see, as you can see, the distribution of elements is not linear and it is not aligned. See, from this node to this node, it is not aligned. So we are not considering these elements to represent the curved surface, fillets, and when we want to create any of the bolts, so we are not using the equilateral trias. So this is the reason for the most of the cases, we are not going to mesh using the volume Tetra. Using the volume Tetra, we are not going to create the elements. Then you can ask me, then how to create the Tetra elements? We'll create the Tetra elements manually. See, I have opened the one more model which we can create the tetra elements manually. As we receive the model, don't create any elements or don't generate the mid surface as soon as you receive the model. Just go with the component and understand the component requirement. The component is I need to create the tetra elements, and the requirement is I need to create manually. And my component does not contain any solid in it. So it is an 2D surface. It is a single surface. It is an enclosed surface, but it is not a solid volume. It is an enclosed surface. To create any 3D surface, my element should be enclosed. To do that, I need to check the geometry. See, I'm keeping it in a wireframe mode. Just keep the model in a wireframe and observe the geometry as we did in the module 2 to create any elements. See, here the red lines are there. It is not allowed. Just fill this one. See, I'm going to fill this surface just to create my 3D elements. And I said to create the 3D elements, I'm just selecting the line. I'm going to fill my solid. Now you can observe, I'm not finding any red lines. I'm not finding any red lines. It means this component is ready to mesh. This component is ready to mesh. Here, what I'm going to do, after selecting the element, then the same way I'm coming for the 3D mesh. Select the tetra mesh. See, here the first option I have chosen, tetra mesh. Select the component and say mesh. See, here tetra mesh is not enclosed. In the status bar, you can observe the mesh is not enclosed. It means it is asking me to create 2D elements. So for creating the tetra elements manually means go for F12 panel the same way how we did in the 2D meshing. In the same way, select the elements, choose the element size and select the elements whichever you want and try to start meshing the component. Here I'm using the R trias or equilateral trias, but using a mixed mode also I can create my tetra elements. And as I showed, see, for creating the curved features like this, I'm going to do the R trias. Now you observe the element flow. Elements are linear. It is aligned to the surface. See, you can see the first node and this last node, how the element flow. These elements we require when we are looking for the curved surface. So what I'm going to do, I'm just selecting the faces which are curved surface and I've given the element density as 4 mm as the global element size and select the surface manually and start doing the meshing. See, I'm just selecting the surface where I want. And here also, if you require any of the washers, the same way in the quick edit panel, select the washer and click on this line. It will create the washers. See, it will create the washers like this. So of the same way, going for the F12 panel, select the surface and start meshing the component. This is how we will mesh using the R trias. But what about the other faces? What about the other faces means? Just come here and check unmeshed surface. See, it will highlight only where and all we are not created the elements. So where and all we are not created the elements. So there we can create the equilateral triangles. But creating a R trias, it is having one disadvantage. The creating a R trias will be more stiffer in the component. It will make more stiffer the component. So when it comes for the flat surface, don't use the R trias, use equilateral trias. See, like this, use equilateral trias. So select the elements, select the surface and start mesh the component, or else directly I'm clicking on the unmeshed surface, say mesh. See, in a single shot, all the elements are created. So we have successfully created the shell elements. So, but we have not created the volume tetra. See, to create the standard elements, to create any of the tetra element, we need to go for this tetra mesh, select the component. In this drop down, you have to select, do you require a simple pyramid or simple, there are the options are there. So we have to click on these options and start creating the Tetra elements. There are the requirements for the shell elements. See, I have created the tetra elements means it is not ready to generate the tetra. There are the corrections to be done for the 2D elements. The requirement from the shell elements. What are the requirement from the shell elements? We'll discuss it. See, I've just created the elements. I'm masking the geometry. What I do now, I just delete the elements. Just for the understanding purpose, I'm just deleting the few elements. See, it's a delete entity. I've deleted the elements. Now I'm creating one component with the name Tetra. See, I have created one component. I'm going to create the 3D elements. Click on the 3D elements. Come for the Tetra mesh. Here, I'm going to choose the Tetra mesh. Here, you can choose the elements also, or you can choose the component also. When you are going to create a component, try to select always with the elements only. Why? Because it will not confuse you. When you are going, the two components are sharing, when the two components are sharing the same component name means it will get confused. So better to go with the elements only. Next, in this drop down, there are three options are there. One is simple pyramid, smooth pyramid, split quads into triads. See, as I said, when you are creating the elements for this in the F12 panel, directly I have used R triads. So directly I can use the simple pyramid or a smooth pyramid. But what if you have created by using the triads mixed mode? So by using the mixed mode also, we can generate the triad, no issues. But the elements, after you creating the tetra elements, the elements will be 3D elements by tetra only. Don't worry about this. Even if your shell elements are mixed mode, you can proceed to create the 3D elements, need not to worry. So in that case, what you have to do here, you have to choose the option called split quad into triads. It means it will just split the quad element diagonally. See, like this, it will just split the quad element diagonally and start creating the tetra elements. And it will start creating the tetra elements. Now, here the elements you can keep for the elements, or you can keep for the components also. Here, always keep swap only. Don't keep remesh. Don't keep remesh. Why? Because the elements which you are going to create, it should be a fixed element. Don't keep the remesh. If you are keeping remesh, always it will try to generate the new elements. It will try to generate the new elements. See, here I'm going to select the elements. I have selected the elements. Here I'm asking to mesh. Here, the global element size, we are not setting the global element size. Why? Because we have already meshed this component with the 4 mm. In the F12 panel, I have given the element size as 4 mm. So here, according to the shell elements, see, according to these elements, the tetra elements will get generated. According to these element size only, it will get generated. But when we are creating the volume tetra, we have defined here. In volume tetra, we have defined here. Here, I have not defined. Why? Because I'm already having the mesh of 4 mm. Say create, select the element, complete element and mesh. Observe in the status bar, say mesh. See, the mesh is not enclosed. The mesh is not enclosed. Why? Because here it is not connected. Here it is not connected. To create any tetra mesh, this is the major check that we have to do. All your elements should be enclosed. So how to fill it means, just go for F3, shift F3, select the component and say find edge. See, here you can see some of the red lines are there. So these red lines are not allowed to these elements are not allowed to generate the tetra mesh. It will not at all generate the tetra mesh. So what we have to do, it should not contain any free edge with it. It should not contain any free edge. So we have to fill this surface manually. So fill the surface manually. Now the elements I have retrieved again, you can see. Now again I will go for the F3. Again I'm going with the shift F3. Select the component and check for the find edge. Observe in the status bar, no edges were found. The selected elements may enclosed volume. We require the component like this to generate the tetra elements. Now my component doesn't have any free edges, so I can create my tetra elements. Go for tetra elements, select the elements, or going by selecting the displayed element, say mesh. See here, I'm asking mesh to the current component. So create one component, select the tetra mesh, select the elements, say mesh. Here I'm giving to current component. Mesh to current component, I'm telling say mesh. It is taking time. See, observe in the status bar. Now it's ready. Now how to review the tetra mesh? See, on the first we have generated 2D elements. On the same nodes, my tetra elements will generate. See, hide the tetra, hide this 2D elements. See, come for just to observe the elements, how the elements are. See, I'm meshing this component again. See, this is a tetra element. If you ask for find it, see, this is a tetra element. See, the elements are attached like this. So I have created my tetra elements. You observe how the elements are inside. You observe the elements. I'm just going by selecting the adjacent elements. So this is how we have successfully created the tetra elements using standard tetra mesh. Using standard tetra mesh, we have created the tetra elements. Now next comes to the what are floating trias and what are fixed trias. The same way, what I have generated the tetra elements in the same tetra mesh. See here, if you come and select, see, float and the fixed trias. The floating trias means if you have a quad element over here, if you have used a 2D mixed mode elements to generate the tria, sometimes what happen, this will, the elements, it will get swap. See, like this, I will show you. See, sometimes it will get swap like this. The elements may diagonally, it will get swap. So always go with the fixed trias only. When you are creating the elements using a fixed trias, it will not alter this diagonally. It will not alter these diagonal elements. Always it will be fixed. See, for this corner 3 nodes, this diagonal element will not swap. It will be fixed. So when you are creating a tetra elements, don't go with the floating trias. Go with the fixed trias only. You have to go with the fixed trias only. So this is a concept of using fixed and the floating trias. See, if it is a shell mesh like this, when you are creating the tetra elements, you may get the faces like this also. It may split the diagonally like this, or else it may split the elements like this. But what happens is when you are extracting the faces or when you are recreating the shell elements using tetra elements, you may get confused. To avoid such situation, always use the fixed trias only. Don't use floating trias. Next, see, in the simple pyramid, we have learnt about you keeping a simple pyramid and the smooth pyramid. See, these are the smooth pyramid. If you're using a smooth pyramid, you will get the elements like this. These are the simple pyramid. When you're creating, see, when the component is very simple, that what we are meshing today, for the component like this, go for simple pyramid only. When you are having a complex geometry with the complicated features, go with the smooth pyramid. Why? Because it will reduce the tech collapse. It will reduce the, see, pyramids like this. It will generate a smooth tria elements. Smooth tetra elements it will create. So we have done with creating the tetra elements using the standard tetra, and we have finished that component. Now next part is what is tetra remeshing. So how to do the tetra remeshing? See, I'm having few elements here. The same way, like see here, if you are not satisfied with these elements, see if you are not satisfied with these elements means you can go with creating the Tetra Remesh. The Tetra Remesh available in the 3D page. Come for the 3D page. Select the Tetra Mesh. Here, the second option is there, Tetra Remesh. See, here also, when you are doing this Tetra Remesh, always go with the fixed only. Swappable means, as we said, it may swap in this diagonally or from here to here, it may get swapped. See, swappable means, see, earlier it is like this. When you are using a floating means, it will split diagonally like this. So doing remeshing also, always go with the fixed only. Don't change this. See, select the elements which you want to remesh. See, first I will select only these elements. I will mask these elements. See, I have selected these elements and will start creating the tetra remesh. Select the element, say mesh, say remesh. See, now it has remeshed. But outer boundary of the faces, it will not change. See, outer elements, it will not change. Why? Because we have kept it as fixed trias. We have kept it as fixed trias. But inside the volume, the elements, inside the volume, the element get a new shape. The elements will get every time you do remesh, it might be in a 2D or it might be in a 3D. Every time new elements will get created. So always be careful when you are doing the remesh option. The remesh option which we use to get a better mesh flow, if the features are not captured properly and when it is failing for the quality, we are going to choose tetra remesh. But HyperMesh is meant for the meshing software and it is a very good tool to create the mesh, to create the elements, and for the meshing also. When you are choosing a tetra mesh, the software will give you always, it will give a better mesh, unless it is a minor features. If it is a minor features and if it is stick on to the quality parameters, then only we are going with the remesh option. Otherwise the software will give you only a better elements. So this is the concept behind the remeshing. So now we have done with the remeshing option. Let's to move on to the quality checks. So when we will go the quality checks, once the component is done, once the elements are done, or when we have created all the checks, like creating the washers or creating any of the features, and we have done with the tetra remeshing also. Now I am done with my meshing. So I'm going to check for the quality parameters. The quality parameters, as I said in my module 2, it is available in the F10 panel only. In the F10 panel, now switch to the 3D. See, 2D also it is there, 1D also it is there. Now choose for the 3D elements. The same way, what all the options are available in the 2D image for the correction of 2D elements, the same options are available in the 3D mesh. For 3D quality mesh, we are going with a TET collapse and minimum and the maximum length and the interior and the exterior angle for triangular elements or tetra elements. We are not, aspect also we will check, warpage we are not checking, Jacobian we are not checking. Why? Because as we know, it is in tetra mesh, warpage and the Jacobian comes only when it is a 4-corner nodes. And as we know, we are not keeping any quad elements, so we are not going to check for the quads. First priority is to check the TET collapse. So what are TET collapse means? Sometimes some of the element collapses the value which is less than this. Which is less than this, we need to create the TET collapse. It means that when you are creating any of the pyramid elements like this, when you are going to create the elements like this, see, when you are going to create the element like this, some of the element, the node of this element, if it is the node of this height is very less than the given value, if the height of this node, which is less than the given value of 0.15, then the TET collapse will arise. The main quality parameter for the 3D meshing, for the tetra meshing is TET collapse only. So how to clear this one? We'll clear the few elements. See, check, I have given the range as 0.15. Click on this TET collapse. See, there are 625 elements. You can observe in the status bar, there are 625 elements are failing. The minimum TET collapse also it will show. The minimum is 0.1 it has, 0.1 it is having. But my requirement is 0.15. So I'm just saving the elements. I'm just saving the elements. So again, I'm just retrieving the elements which are failing for the quality. See, these 620 elements are failing for the quality of TET collapse. It is failing for the quality of TET collapse. So how to clear it? So here, when you are clearing the quality parameter for 3D elements, means that too for Tetra elements, first go with the Tetra remesh only. The best option to clear the quality parameter for the Tetra elements is remesh. So I'm going to select only these elements. See, I'm going to select only these elements and say remesh. See, now it's ready. So what I'm going to do again, after I'm going now check for the TET collapse. See, earlier it is 626. Now it is 625 elements are failing. Say save failed. F5. Retrieve the elements. Mask and reverse. I'm doing. See, unmask all these elements. See, I'm interested only in these elements. See, like this you have to do. It means it is attaching to the adjacent elements. I will go for the again Tetra remesh and do the remesh for these elements and say remesh. Now again come for the F10, check for the TET collapse. See, now you can observe it here in these elements. In these elements, you are not finding the failed elements. See, you're not finding the failed element. It means the TET collapse has cleared. So this is the remesh option of clearing the TET collapse. But what happens when it comes for the manually, when you have to create manually? So I'm going to retrieve the same elements again. So I'm just showing how to clear the TET collapse for this element. See, select any one element. See, I'm choosing this element. See, in the same F10, click on this element. See, it will show the TET collapse. See, it is showing 0.106. It is showing. Now, what is my requirement is it should be 0.15. So, select the node of this one. See, select the node of this element. Define the plane and start correcting the value. Now, check every time when you translate the element. You check for this one. See, now it is 0.12. But my requirement is it should pass with the 0.15. Now again come for F10, check for this element. See, now it is 0.16. It is now this element is passing for the TET collapse. Like this, you have to clear the TET collapse or manually or with the doing remesh option. These two options are very important when you are clearing the quality parameters for Tetra elements. Doing remesh option or by translating manually, we have to correct it. Then the other quality parameters are, see the other quality parameters, minimum and the maximum length and duplicate elements. See, in the same F12, F10 panel, as I discussed, see the minimum length, check for this minimum length, it is 13 elements are failing. So these elements I have to correct manually. See, these are the elements which are failing for the quality of minimum element length. Now check these two elements. It is 0.17. Now I'm making it for 1.201. I'm making. Now again come for F10. Now check for this one. Minimum element length. See, it is 1.201. Now it is not failing for the quality of this one. So this is how you need to correct for the maximum length also and interior and exterior also. See, you need to correct manually only by doing remeshing only. You need to clear the minimum and the maximum angles for these Tetra elements. Now the other quality checks are duplicate elements. See, duplicate elements are not at all allowed even in for 1D, 2D and 3D elements also. So don't keep the duplicate elements. Why? Because it will add extra mass to the component. See, I need only 2 elements here. What if it is duplicated for 2? 2 plus 2, then it is a 4. Obviously, it is going to increase the mass of this component. So duplicate elements are very dangerous. If you are keeping the duplicate elements and you are carrying the simulation means you will not get a desired values. the values or the results what you are getting, it is not the perfect ones. So when you are finalizing your model, always check for the duplicate elements. See, in my component, I have manually created some of the duplicate elements. See, as you can see here, compared to these elements visualization and compared to these element visualization, there is a difference. It means it is having some duplicate elements. See, if you click on that, observe in the status bar, 2469 elements are duplicated. See, click on these duplicate elements. So how to clear the duplicate elements means just save the duplicate elements and delete it. I'm going to retrieve the duplicate elements and I'm deleting. See, now observe it here, how it has come to normal visualization. Now again, every time you do any correction in HyperMesh, every time you do translate or you do mask, so every time you need to come back to F10 panel and check it again. When you are deleting or when you are translating, when you are clearing the quality, so or when you are moving for the geometry deviations, after doing the geometry corrections or after doing the elements correction, always come for the F10 panel and check for the other things, the same quality parameters which I have discussed, the same quality parameters. Check for the duplicates. See here, observe in the status bar, 0 duplicate elements were found. Now, my model is ready with the duplicate. It is free from the quality. It is free from the duplicates. Now, the other important check for the 3D element is 3D faces. As I said, see, I'm just extracting the 2D faces. See, since this component is having 3D elements also, see, this component is having 3D elements. Now, I want the 2D elements for this one. I want the 2D elements. As soon as you finished your 3D model, at the CA, what the CA industry is following means we require 2D faces along with the 3D elements also. We require 2D faces also. So I have only 3D elements now. So I need 2D elements also. How to create the 2D elements using 3D? There is an option available in HyperMesh. Using 2D, we can create 3D elements and vice versa. Using 3D, we can create the 2D faces also. So I will show that option. I'm in the 3D, I have only the 3D option. I'm going with the tool page. I'm using the faces. Select the component, find faces. See, these are my 2D elements. So you can observe it here. The highlightation of this one, see, here it is halo. Inside it is halo. These are the 2D elements. See, these are the 2D elements. So what I will do, I will create one dummy collector. I will move these elements to this collector. I'll move all my elements to this collector. Say move. See, these are my 2D elements. Now I have 3D elements also. I have 2D elements also. We can create 2D, we can create the tetra elements using 2D, and we can create the shell elements using 3D. This is one of the best option which is available. When you are finalizing your 3D elements, always send your model with the 2D elements also, or with the 2D. By extracting the faces, you can create the 2D elements also. Now, one more thing I wanted to tell in the tetra mesh. See here, in the tool, if you come for the 2D page, there is an option called order change. See, you can change it for first order. First, I will change all my elements to the first order. See, all my elements I have changed to first order. It means you just keep on adding the nodes. It is not dividing to the mid node. Wherever you can observe this one. You can observe closely. See, now the same way in order change, select the elements, say order change. Observe in the status bar, the order changing is done for these elements. So why I'm stressing in 2D only in the tetra machine means usually in the CAE industry, we are going to simulate using the second order tetra only. Now check these elements using some of the nodes. See, the mid node has created between the corner node. This is the second order element or parabolic element. So this is the basic concept of creating the tetra elements. These are the basic concept to create any tetra elements. In this module, we have learned for geometry correction for 3D. We have created the volume tetra, and we have created the standard tetra elements. For the standard tetra elements, we learned for to create what are the floating and the fixed trias, our remeshing option, and we have learned about the quality parameters. The same way, when you are creating the quality parameters for the 3D elements, always your geometry of the element, your your element should not go behind the geometry of the element. It means, see, always all your elements should be like this only. See, you should not go here. The 3D elements are there, so I am not able to move. It will not come out of the geometry. I will show you how it is. See, I'm just checking the distance. I will translate this node inside. Select this node. See, it should not be like this. It should not be like this. All your element should capture the geometry of the CAD. All your element should capture the geometry of the CAD. These are the important quality parameters that we check when you are clearing the, when you are doing the, or when you are finalizing the 3D quality. See, T edges should not be there, or free edges should not be there. Duplicate element, don't keep the duplicate elements. Whatever the elements you create, 1D, 2D or 3D, don't carry with the duplicate elements. And it should not be the geometry deviation. Geometry deviation means, as is shown just now, that is a geometry deviations. These are the basic concept, or these are the basic operations that you should know to create any of the 3D elements, or to create any of the Tetra elements. In this module, we are all discussed about these things, from creating the solid elements to the clearing the quality parameters of the Tetra elements. And I hope you understand these concepts which I have discussed to create the 3D elements. And after this webinar, you can start creating the elements with the component which we have given, and try to clear the quality for the same elements also. And I hope this video is very helpful for creating a 3D elements. Thank you. If you're having any doubts and all,